Hello all. In this PPT, we are going to see about implementation of linked list in C++, understanding linked lists and their operations. An overview of linked list. What is a linked list actually? A linked list is a linear data structure, right? Consisting of nodes, and each nodes has values and pointers. The values are nothing but the node that stores the data, and pointers are nothing but the points to the next node. The last node's pointer is null, indicating that end of the list. Diagram. A simple linked list can be represented as head node, node in between, and the last node is tail node, and last node points to the null. Now let us create a node class. So, and we'll be creating linked list and we'll be performing various operations in this PPT. So what are the nodes that we are going to create are int value node that stores the data, and another one is next. So we are creating the node structure, struct node, and we are creating the value node, that is data node. Another one for pointer node, that is nothing but a next node that points the next node address. So now we are going to create a linked list class. So in that under the private access specifier, we are going to create a head pointer, and then the methods that we are going to apply in the linked list. Append value, void append, and the parameter is passed as value. New node is created if not equal to ed. Ed is equals to new node. If so, not equal to ed means there is no any list present there. So whatever the node, new node that we are creating, it's going to be the ed. And then node temp equal to head, while temp is equals to temp next equal to new node. Adds a new node at the end of the list. Append method is used to add a node at the end of the list. Method. Prepend method is a method where we can add a node at the beginning of the list. So void pretend, it's the method name, and the value we are passing as the parameter. Node, new node. In the new node, we are just passing the value, and then we are pointing to the next node, and that next node is going to be the head node, and head is equals to new node. So the previous node, which was earlier the head node, we're going to remove that. Size, head, tail. To calculate the size, we use size method, and head and tail are the pointer. So int size, int count is equal to 0. Node temp is equal to head, while temp count plus plus temp is equal to temp next. So the next node is going to become the temp. So return count, node head, return head, node get tail if head return null pointer. Node temp is equal to head, while temp next equal to temp next. Return temp. So get list size and the first and last node. So we will be using size, head, and tail. At index method returns the node at a given index. So for that, node at index method we are using, and int count is equals to 0. Initially the count is 0 and node temp is equal to head. So in the temp we are storing the head, while temp if count equal to index, return temp, count plus plus temp is equal to temp next. Written null PTR. Pop. Pop is going to delete any node in a particular list, right? So whether it is an initial or initial node, or it is an end node, or nodes in between. So we can to delete the node, we'll be using pop or delete. So void pop, if not equal to ed, return. If not equal to ed next, delete ed. Ed is equal to null ptr, return. Node temp is equal to ed, while temp next temp is equal to temp next. Delete temp next, and then temp next equal to null ptr. Summary: created a custom linked list and node class, implemented core list operations, and learned about pointers and memory handling.